Hello and welcome to today's lecture. I'm excited today to teach you about programming in Python. But why is it interesting to learn to program in Python? First of all, it's a simple language. As we saw in the previous lecture, Python was one of the high-level languages, meaning that it hides a lot of details from the architecture of the computer to be worked with. So it intuitively becomes easier to program with it then. And it has an easy or a straightforward syntax, meaning that when you look at the statements that are written in Python, you can easily guess what they are intended to do. And it makes your programming easy as well. The other advantage is that it's a cross-platform language, meaning that once you write a code that can be run on an operating system, for example, on Linux, it is also able to run on other operating systems. This is not the case with all programming languages. It is often the case that when you run a program that fits some operating system or some platform, then you need to adjust it so that it can run on another operating system. And as we discussed in the previous lecture, Python is an interpreted language. Interpreters execute each line of code separately, and they proceed one by one in the instructions. It makes them to be easier to debug then. And the Python implementation is open source, so everyone can have access to its implementation. So you can, so then it's free to use, and you can easily practice anytime you want. There are mainly two versions of Python, being Python 2 and Python 3, but we use Python 3 in this course because Python 2 is not maintained anymore, and there are some instructions in Python 3 that are much useful but didn't exist in Python 2. So in this lecture, we will cover, first of all, let's see. So we will see how you can install and run Python on your computer. Then we will see how different programming constructs that we discussed in the previous lecture, such as variables, operators, data types, control structures, are defined in Python. And what are different program parts in Python, for example, functions, procedures, main program, etc. In order to install Python, you need to follow the link that I have put here. It offers different installation files depending on the kind of computer that you have, the operating system, etc. So you should just download the file and follow the steps for the installation. I hereby recommend you that you follow the slides one by one with me, meaning that you stop here this lecture and go and install Python, and then you continue to the next part. Because we are going to talk about different statements, different program parts in Python, and if you just listen and look at the lecture, you will not gain much. What is important is that you practice them on your own. So now we assume that you have installed Python on your computer. Let's see how we can use that to run a Python code. When you install Python on your machine, a small editor called idle is also installed on your computer. You can use idle to write programs, execute them, and debug them. So let's see in my computer, where is idle? So now that I'm using Windows, I just press the start button and type idle. Then I can open it. And here I have two choices. Either I use this sort of interactive session, meaning that I just write Python statements and press enter. It simply just runs them and gives me the output. Or I can use it in another way, which I prefer the most. I open a new file and I write my program there. Then I should save it, of course, before I can run it. I save it somewhere. And you see the Python files have mainly the .py extension. I give it a name, save it, and now I can run it. I go to the Run menu and choose Run module. I can optionally press F5 for running. So here you see the shell opens, and this is the start of running my program. It starts here. You can see here the file name and the path to the file. And here is the output. So using idle is not the only way to write and execute Python programs. There are several Python IDEs. IDE means Integrated Development Environment, which gives you possibility to run your code, debug your code, do version management, etc. One of the very popular ones is called PyCharm. The other one is Visual Studio Code. Visual Studio Code can be used for basically any programming language, but PyCharm is for Python. There are other IDEs as well. The term IDEs is usually talked about when it comes to programming, because whenever you want to program, you need an environment to be able to do your coding and execution, etc. This is called IDE. So you can choose whether to continue with idle or install another IDE. So the first thing we have tried is to use the print function in Python. You saw it's easily written as print, and it can simply get a string and input it in the output. This is a very simple string. We will see later on that we can have numbers in it that are not fixed. For example, we can put some variables of the program inside the string that wants to be printed out. So now let's see what are variables and data types in Python and how we can use them. We can, of course, have numbers in Python, and there are mainly two types of numbers, being integer numbers and floating point or decimal numbers. And we can have also booleans in number, which we have discussed before. They are true, false. They get true, false values. And we can have strings. We will see in the coming slides how they are formed. And we can have compound variables, meaning that they are composed of several items. In Python, lists and tuples are very popular. We will see them one by one. And we will see how we can convert from one data type to another one. So let's start with numbers. Here you see a few lines of code that are using both integers and floating point numbers. We can try them in our program now. So let's see. So let's x is 7, box float is, these two are different because one of them is decimal, the other one is integer. And now I just simply print them. So you can see that the print function can print other things than strings. It can print variables for us. So I save it and use F5 to run it. So it is printing those two numbers as well. So here the syntax of Python requires that you open and close parentheses. Let's see what happens if I forget to put this part, for example. I save the file, press F5. So you see I get an error from the idle editor. It says unexpected end of file while parsing. Parsing is a step before executing your program in which the syntax is checked to see that you are using the grammar of Python correctly. So here it expects the parentheses to be closed, but it is not. It says I reached EOF. EOF means end of file. I reached end of file, but it wasn't expected because it expects actually the parentheses to be closed. And it highlights it so I can come and fix it. Whenever you get an error message, if you really don't find what is the reason for that error message, you can write the expression that is given to you as error message and Google it. And usually you're going to find good hints about what the reason might be for that error message that you received. So the file completely executes when it doesn't have any syntax box. So let's go back to the slides. So let's see what are strings. So strings, as I talked about in the previous lecture, are a sequence of characters that follow each other. There are different ways to define strings in Python. One way is to put your string inside single quotations, as we have here. The other way is to put it inside double quotations, and they work very similar to each other. Let's see. So here I have put my string inside double quotations. I can also put it in single quotations. Let's run it. So you see it treats them the same. We don't see any difference when it is printed out. But there is one small advantage when you use double quotation. It is that if you have apostrophe in your statement, in your string, then there will be no problem. So let's see an example. I use my variable and my string variable. So I have apostrophe here, and I can print the string and run my code without any problem. But let's see what if I have apostrophe inside single quotations. You see already the color of this string has become different. This shows that this is not treated as a correct string. There should be some problem. You should notice the colors that are used in Python or any programming language that you're using. They usually give good hints to you about whether or not you are following the syntax correctly. For example, you see here the function print is always written in a special color different from the variables, for example. The strings have a special color. The actual color differs from IDE to IDE and from the settings you choose for your IDE, but the same color pattern will be consistently used inside your program. So if I, for example, happen to do a mistake here and write print 2 instead of print, you see that the color changes. So it's a good hint for me to realize that there is some problem here. This print is different from the other prints. So then I come and fix it. Now let's run this problem with a problematic string here. I should save it. You see it says invalid syntax, and it's highlighting the part. Sometimes it highlights the actual part which has a syntax issue, but sometimes you are misled because the parsing doesn't really understand which part in your code is buggy. So you should look around here and there to see where is the actual bug in your program. So here I understand that I cannot have apostrophe inside single quotations. And also get strings or numbers as input from the user. Let's have a new variable. So that is done usually with a function called input. And whenever we have functions, we need to have open and close parentheses right after function names. And inside the parentheses, we put the input arguments to the function. As arguments here, we can write a string that is shown to the user. For example, I say, enter your name. And then I run this code. So you see here, after all these printings, I can enter a name and then press enter. This will then read the name. Let's see if it actually can print it. Save it and run it. So I entered my name and entered print. So and now it has printed out my name. Let's go back to the slides. So this was for strings so far. And we discussed that whenever we have double quotation, we can have apostrophes easily and we don't need to worry. So let's see what are lists and why it is good to use them. Lists are simply a bunch of variables. They store a bunch of variables. You might say, okay, why do we need lists? We can define as many variables as we want and we set their values and that's it. But sometimes you don't know how many variables you will have, or you have some variables which are all different instances of the same thing. For example, you have several students in a class, all can be called a list of students, and then you can access the students one by one through the list. There are several operations on a list that we can do. First of all, we can create an empty list with brackets, and then we can add elements to our list using the append function. These functions that I'm introducing are built-in functions in Python, they are defined, they are implemented, but we don't care about their implementation, we just use them. So here we have a list which has these elements 1, 2, 3 being added to that. And we can easily access the elements inside the list using index. The indices start from 0 and continue to the length of the list minus 1. So in this case, you saw we had 3 elements added to the list. The indexes start from 0 and continue up to 2. So let's try lists in our exam, in our test file. We can have an empty list, or maybe we can already add some elements to it. For example, I can define some variables beforehand, and I put them in my list. I just have to separate them using comma. Then I append another value to my list, and I can have repetition. So here I add 10 again. Now I ask it to print the item with index 3. So let's see. So it prints 10 for me because the length of my list is 4. So index number 3 is actually the last element, which is 10 that I have added last to my list. In Python, we can easily iterate over the elements inside the list. What does iteration mean? It means that we simply start from the beginning of the list and view or access the elements one by one. The syntax for iteration over a list is very easy in Python. We will see it now. So as you see here, we have a for loop. We will go to the details of for loops in the coming slides, but it is enough to know for now that in this for loop, we start by the for keyword. Then here we have x, which can have any other name, which means any element inside the list. And then we have the in keyword. These keywords are very important when you want to have the correct syntax. You cannot write anything different from them. And then we have the name of the list. So it basically starts from the first element in the list and accesses all of the elements in the list one by one to the last element. And then we can do an operation on the elements that we get. Here we are simply just printing them. So let's try this part in our program. So for x, or I can give it any other name, item in my list, print item. So here you see it is printing out all the elements in the list. But before this for loop, there was another print statement which prints this element, and the rest correspond to the for loop. As we saw, we can access the list elements by their indices, but the index that we are using must be correct. If we use indices that are not correct, we will receive an error. For example, the index that we specify here should not be beyond the length of the list minus 1. Here we have 3 elements in our list, so the length of the list is 3, so we can have only indices from 0 to 2. 10 is not acceptable. And if we execute this line of code, this will generate an error which says we have this type of error, index error, list index out of range. The acceptable range, as I said, was between 0 to 2, but now that we are using 10, we are going outside the range. And it is showing where in the file this error is happening. It is saying line 2. Let's try it now. So let's print my list 3. Even 3 is still is legitimate. Let's try 4. So you see we got the same error. When you get a kind of error, you don't realize what it means. You can just copy that and Google that. Most likely you will find out what can cause that error. But here in this case, it is very clear and the line of code is also specified. So I can easily go inside my code and find it. And there is a way to show the line numbers. We can use it, which improves the readability. Let's see where it was. Show line numbers. I chose it from options. So on the left hand side, you see the line numbers. At line 11, we had an instruction that caused error. We can come here and fix it. In this case, I just simply remove it. Another compound element that we have in Python is tuples. Tuples are defined very easily in Python. In other programming languages, we need to define them ourselves, but it is very convenient that they exist in Python. Tuples store multiple items in a single variable, and they are defined using parentheses as opposed to lists, which were defined using brackets. So these are the syntactical differences that we need to pay attention to. So tuples can, for example, be used to give information about different aspects of the same thing. For example, here we define a tuple for a student, and in that we can have its name and her age and her height, for example. And then whenever we print the tuple, it will print all the information stored in the tuple. And there are several functions defined on the tuples. And what is important is that the order of elements inside the tuple is very important and cannot be changed. The function len on a tuple returns the number of items. For example, in this case, we expect the print len student to return 3 because we have 3 elements here. And we can use the indexing system that we use even with lists inside the tuples. So the first item is indexed 0, the second one is 1, the next one is 2, and so on and so forth. Pay attention that the index is always the position -1. For example, the item that comes in the first position has index 0, and so on and so forth. We can use the list function, which is built in Python to make a list from a tuple. You see, lists and tuples have some similar concepts. They consist of several items and they have indexes, so they can be converted to each other. And here we are updating the element in the index 1 with a new value. And we can build tuples from lists. because y, you remember, is a list built on the tuple student, and then we can again convert it to a tuple. So lists and tuples simply convert to each other using built-in functions in Python. And we can add elements to tuples simply in the same way we had with lists. We use the append function. So let's try these lines in our code. So we have students, and in order to define tuples, as I said, we should add parentheses, and we pass the name to it. And for example, age, and we can have, for example, height and other information, phone number, for example. And then we can simply print it. Print student, and we can turn the student in a list, student info, I call it. I use the function list and pass to it my student tuple. So let's see what we have. Let's now print student info. Let me close this here. So it seems that this is not a legitimate value, maybe because in numbers we are not supposed to start with 0. So you see here, first my tuple is printed out, and since it has parentheses, I realize it is a tuple, and in the next line, a list built based on the same tuple is printed out, and I understand it is a list because it has brackets. So as we have already seen a little bit, we can convert from some type to another type. For example, we could convert from a list to tuple and vice versa. There are two kinds of type conversion in Python. One is called the implicit type conversion. It is the data type conversion that is done by the compiler or interpreter of Python during runtime. Whenever it is needed, it makes that kind of conversion. For example, in this example, you see that A is an integer variable, but B is a floating point number or a decimal number. When I want to calculate their sum, sum needs to decide what type it will have. Sum needs to be a floating point number, otherwise it will lose some information. Because we know sum of 5 and 5.5 will be 10.5. If sum is an integer, it cannot store 10.5. It can only store either 10 or 11. So Python is smart. It tries to find the data type needed to maintain the precision that we would desire. So here it converts A implicitly to floating point. So it will be basically 5.0. And B is also floating point, and the result will be floating point. Because we know simply that when integer is summed up with a floating point, the result should also be floating point. Otherwise, we lose some precision. And then if we print the sum, we will see that it actually is floating point, but we didn't explicitly do any conversion. It was Python that took care of this conversion. Because of this, it is called implicit. And there is also a function type that we can use, which displays the data type. Let's try this. So I want to call it integer floating point integer plus floating point sum. Sum looks like a keyword because its color is different. So let me call it something else. Sum of vars. It means sum of variables. Now the color is black, and then let's print type of this variable. Sum of vars. Here I have a hint that whenever I have a print function, I can give it some value to print, and I can separate the values to be printed out, and etc. So let me run it. So you see the value for some of those two variables is printed out, and it is floating point, and it says the type of it is float. There is another kind of type conversion, which is called explicit, or it is also known as typecasting, meaning that the programmer clearly and explicitly defines the conversion. And for doing that, there are usually built-in Python functions that we can use. For example, let's see here. So here we have A, which is an integer, and B, which is a string. You should not think that it is an integer. Since it has double quotations, it is regarded as a string. So first of all, we have A plus B here. We will see what its result will be. But in this line, we convert B to integer, which means that Python looks at this string and tries to extract from it an integer. And it can sometimes succeed. In this case, our string can be easily converted to an integer. This is not the case with all strings. And then we have summed up A and B. Let's see if the result is different in these two cases. So A is 100, B is 200, but as a string. Let's print A plus B, and then let's convert B to integer. And then let's print A plus B. Save it and run it. So you see we get an error at line 4. It says int and the string cannot be summed up together. It says that the kind of error is type error, unsupported operand type. So for different data types, there are different operands that can be used on them. So here for an integer and a string, str means a string, we cannot use plus. So let me comment that out. Using hash character, I can comment out part of the code, a line of the code, which means that this part will not be executed later on. This is just like a text that Python ignores. Let's run it again. So you see we have the correct result because this time we had explicitly changed or converted the data type to integer. So here is the list of built-in Python functions for type conversions. For example, we have seen so far int, which receives an input and tries to convert it to integer. And the float does the same thing, but that it converts the input to a floating point number. Str converts to string. List we have already seen, and tuple as well. They they convert the data type to tuple and list, and there are other functions as well. We have already seen in this lecture a few operators, for example, to sum up to integer and floating point numbers, and we also tried to sum up an integer with a string, which didn't go through. Let's see what are the operators in Python. There are different kind of operators. For example, we can have operators used for comparison. We can have arithmetic operators, logical operators, bitwise operators, which are used for bits of data. We can have special operators for strings and also for lists. So let's see here. Python uses Boolean logic to evaluate conditions. And the Boolean values, remember from the previous lecture and also the lecture on binary numbers. The Boolean values are true and false and are returned when an expression is evaluated. So here we have two variables being x and y, and we want to make some set of comparisons on them. For example, we want to see whether or not x is equal to 2. When we want to check equality in programming, usually we need to put equal sign twice, like here. This is an expression which will be evaluated by Python, and it will print out true because x is actually equal to true. But the second expression will print out false because 2 is not equal to 3. And checking if a variable is smaller than some value or greater than or equal to is simple. It's like the mathematics we have learned at school. And we need not only have variables, we can have expressions that are compared to other expressions. For example, here 2 times x is checked against y, and we want to see whether or not they are equal. 2 times x is 4, y is 10, so 4 is not equal to 10. So this expression is valid, so true will be printed out. Let's try them now. So let's print out A equals B. If you just write 1 equals character, it will not give you the intended result. Let's print out A greater than B. Let's also print out 2 times A is equal to B. Let's run it. So the first one is false because 100 is not equal to 200. The second one is also false, but the last one is true because 2 times 100 is equal to 200. We can have arithmetic operators in Python as follows. We have simply addition and subtraction, multiplication and division operators, very similar as we would do in mathematics. Just that for multiplication, remember that asterisk is used. You cannot use x, for example, or you cannot use dot. So here we have a legitimate expression which is using arithmetic operators, and the Python will normally calculate this value and print out the and can, for example, print out the result or store it in another variable, etc. We have a special operator used usually in programming, which is the modulo operator, and it remains the integer remainder of a division. For example, here 11 modulo 3 will remain 2, because when we divide 11 by 3, the remainder will be 2. And there are other arithmetic operators such as power. When we want to write, for example, 7 to the power of 2, we need to put 2 asterisks followed by each other without any space in the middle. Let's try some of these. For example, let's try a to the power of 2 here. And let's print a modulo 3. So you see here, a to the power of 2 is 100 times 100, which is 10,000. And 100 modulo 3 means the remainder of dividing a by 3, which will be 1. Now let's talk about logical operators. You remember logic gates? We had operations like AND, OR, XOR, etc. They also exist in programming languages, and we can use them. For example, here you see we have different conditions which will give us true or false, and between them we can have AND, OR, XOR, etc. So the first one is saying check whether or not name is equal to John, and we see that it is the case. The second one says check if 8 is equal to 23. Both of these hold. So all this condition holds. And here we have an if statement. We will see it in more detail, but it is very intuitive what it does. When this condition holds, it will execute the code that comes inside here. So because we see easily that these two conditions hold, this line will be printed out. And in the next condition, we want to see whether or not name is equal to John or name is equal to Rick. So as soon as only one of them holds, this if condition will return true, and the code inside it will be executed. We can even have not to inverse a condition. Inversing true will be false, and inversing false will be true. In Python, like any other programming language, we have the bitwise operators. Bitwise operators perform the logical operations on operands bit by bit. When we want to see how they do their operations, it's good to have the binary representation of the numbers so that we can see really what's happening. So for this purpose, we can use the bin function, which is built in Python and returns the binary representation of numbers as strings. Let's see what are the bitwise operators. They are the logical operators we have already seen in previous lecture. So for example, there is AND operator. It is written with ampersand. So A and B in this case means that the AND operation will be done on the first bit of A and first bit of B. Also on second bit of A and second bit of B. So the bits are considered separately and the operation is performed on them, and their result is stored and returned. And then we have bitwise OR, which does the same bitwise thing, but using the OR operator. Then we have XOR, which performs XOR, and we have two interesting operators which are sometimes used in programming. They are called shift left and shift right. By shift left, they will basically move the bits of the input to the left. And how much they move them to left is determined by B. So for example, we can say move the bits of A just with one position to left, or we can use two positions. We will see them in an example. There is a similar thing which is called shift right. Shift right means that bits are moved to right. Moving means that, for example, if a bit was previously at position 3, for example, when it is moved once to right, it will be now in the second position. And then we have to, of course, drop the rightmost bit. And the last operator is not, which will inverse all the bits. So what it does essentially is that because the binary representations are considering 2's complement, so when we invert the bits, we will change the sign. For example, if we have a positive number, after inversing, we will have a negative number and vice versa. So I have written some examples here for you, and I will show them I will show them in a real program as well. So here we see we are printing the binary representation of integer value 10. It will essentially print 0B1010. This 0B is to say that it is the binary representation, and then comes the binary representation, and bits that were 0 and were to the left are removed. So it starts with the first bit, which is 1. A binary representation of 10 is 1010 because 10 is simply sum of 8 and 2. So the bits that correspond to 2 and 8 are 1 and the rest are 0. And in the next line, you see that the binary representation of 4 will be printed out, and then we are doing different sort of bitwise operations on that. Let's see them in our Python program. So here, let's print the binary representation of 10. Let's also print the binary representation of 4 first. That's good for now. Save it and run it. So you see here, this is what we expected. This is the binary representation of 10, and this is the binary representation of 4. Now let's do some bitwise operations. So we want to see the binary representation that corresponds to 10 and 4. So the input or operands you see are integer numbers, and the result is also an integer number, but we want to see how its binary representation is, so we use this bin function. So the result is 0 because when you see here in the binary representation of 10 and 4, when we start doing bitwise AND, we see that the first bit here is 0, the first bit in here is also 0, so 0 and 0 is 0. And when we move on to the second bit, we see that only one of them is 1, the other one is 0. You know that AND will only return 1 whenever both values are 1. So here just one of them is 1. So the result will be 0. The same is for the next bit, only one of them is 1. So, and the last bit here is 1. But in the representation of 4, we don't have any bit here, but this is because all 0 bits to the left are removed for simpler representation, but they exist, they are 0. So 1 and 0 will be 0, so the result is 0, essentially. Now let's try bitwise OR. Or 4. So you see for bitwise OR, there are some bits that are 0, they are 1, because we had, in the first position, we have 0 or 0, which is 0. In the second position, we have 1. And here we have 0. So the OR will result 1, because as soon as just one of the operands is 1, then the result of OR will be 1. And in the third position, we have a 0 here and a 1 here. So we will have 1. And in the fourth position, we have a 1 here and essentially a hidden 0 in here, which will again result in 1. And we can see it's an integer representation as well. So if I just simply print 10 or 4, it will return the integer representation. So you see here, 10 or 4 is equal to, when we do bitwise operation, it will result in 14 integer as integer. So now let's see what are shifting. So if I get 10 and shift it once to right, so here I will specify how many bits I'm going to shift it. So it can be 2, it can be 3, it can be as big as the number of bits in an integer number. So here I simply just choose 1 and do the shifting. So let me open a new shell. So here you see 10 shifting by 2 has resulted in 5. It's like dividing by 2. Whenever you move the bits to right, you are kind of reducing their power. So consider if a bit is in the third position, is moved once to right, then it will be in the second position. And we know in the binary representation, positions determine the power of 2. So when we move to right, we are reducing the power of the bits. And when we just move by 1 bit to right, we will kind of divide the number by 2. If we move them by 2 bits, we will divide them by 4. We can see it now. So let's print 10 shifted 2 times to right, and we want to also see its binary representation. So again, I use the bin function and run it. So you see here 10, when it is shifted once or 1 bit to right, it is divided by 2. When it is shifted twice, it is divided by 4. What we see here is we don't, maybe you expected to see 2.5, but this is not what we have in binary representation, because when we discard the bits, we will lose the remainder. So here the representation of 10 was 1 0 1 0. When we move it twice to right, we will basically remove these 2 bits. So our representation will be 1 0, which is what we expect, which is what we have here. Let's see also shifting to the left. So I remove this for more stability. So I move 10 once to left. And I would also like to see its integer value. So here we expect to have the opposite. So here, because we are moving the bits to left, we will increase the power. So now in this case, we are moving just 1 bit to left, so the number will be multiplied by 2. If we move them 2 bits, the number will be multiplied by 4. Let's see the results. So here you see we had the representation of 10, which was 1010. When it is moved to the left, you see we have one extra position at the right because we are moving the bits to the left. We have to fill in this empty place with something, and it is always filled with a 0. There are some cases that we have like a circular movement, which is not what we are going to discuss now. So in this case, when we move, we will fill the empty places by 0. And you see the value has doubled because this 1 that we had before was showing a value 2. But now that we have moved it to the left, it is showing the value 4. This is the same thing that happened to the other one. This was showing before the value 8, but now that we have moved it to left, it is showing the value 16. If we shift them more to the left, they will be multiplied by other powers of 2, like 2 to the 3, depending on how many shifts we do. So if we move them by 3 bits, for example, the number will be multiplied by 2 to the power of 3. See here. So you see here, the number, which was 10, is multiplied by 2 to the power of 3, which is 8. So we have 80 here. And you can see easily the bitwise representation. We have filled in their empty positions in the right with 0. So we have essentially increased the previous bit's power by 8 times. And what we should also try is the not bitwise operator. So let's print not 10. This will return us the integer value that corresponds to it. So since 10 here is a positive number, when we inverse its bits, we will get a negative number because the binary representations here are 2's complement. So the leftmost bit is always reserved for sign. When we inverse it, we are actually reversing the sign of the number. And let's see its binary representation. So you see here we had 1010 as the binary representation of 10, and it is telling us that when we inverse its bits one by one, we get the representation for -11, and it has showed its binary representation like this. So it has put minus to show its sign, and then it has written here the binary representation for 11. It has not actually showed the actual 2's complement representation. It has shown the signature, the sign separately, and the binary representation for 11 separately. If we want to see how its 2's complement representation looks like, we can follow the instructions in the lecture about binary numbers and 2's complement numbers. So that was for bitwise operators. We have some operators that work with strings. For example, we can concatenate several strings together. Concatenation means that we put them together so that they form a single and a bigger string. So here, for example, we have a variable, hello world, which contains several strings together. The first one that contains the word hello, the second one, which is just a white space, and the third one, which has the word verb. So we will have a big string that contains all these 3 strings together. We can try it. And for concatenation, you see the plus operator is simply used. Print hello world. So you see now our string is not anymore one of those smaller ones. It's the combination of all of them. We can also multiply strings to form a bigger string that repeats the same thing over and over. This might also seem interesting. So, for example, we can have a hello that here we are going to repeat it several times. So you see the same thing is repeated as the number of times that we have specified. There are also operators on list. We have already seen some of them. Here are another one is introduced. So it is again the plus operator that is used on list. This will also join two lists together in the order that is specified here. So for example, here we have two lists, the list of even numbers and the list of odd numbers. And we want to join the list of odd numbers to even numbers. And first we will have odd numbers in our new list, followed by even numbers. Let's see how it works. So odd numbers, I will write smaller list to save time. Sorry, even numbers. Odd numbers. All numbers, all numbers. I could not use all because you saw its color changed, so it showed that it is a keyword that cannot be used for name of a variable. So odd numbers plus even numbers. You can see that the plus operator is doing different things when it comes to different data types. So in integers or floating point numbers, it simply sums those values. In strings, it concatenates them. In lists, it joins them. So this is why the data types always matter, and we need to always keep track of what data types we are using in our program. So I have an error because so it is saying name error, name even number is not defined. It seems that the error is happening at line 3. It seems like I am misspelling name of some variable. So here I had even numbers. I have dropped S here. So now let's run it. You see that the list of odd numbers came first and then followed the list of even numbers, and they are put together in a single list. These operators on list are something that has made Python very easy to use. We could not have simply this operator in many other programming languages. We needed to implement a function to join two lists together or use other built-in functions that are not as easy as just a single operator, as easy as a plus. We can also repeat the lists in the same way as we would repeat the strings. Let's try it here. So I want to repeat the odd numbers twice. So you see they are repeated one after another. Now let's see how we can define and use control structures. We talked about control structures in the previous lecture. We said that in almost any programming language, we have conditional statements such as if and else, and we have loops such as for and while. We want to see how they are defined in Python. What is the syntax and what is the semantics? So let's see the syntax of if statement. In the syntax of if statement, we need to first write the if keyword. Then we need to add the condition or expression that shows the condition. And then we need to put columns. Then comes the body of if statement, meaning the code that will be executed if the condition of if is true. And what is very important here is that the body of if and also the body of other conditionals and loops, etc., always need to be indented. In Python, the way to show that the code that depends on another part of code is by using indentation. In other languages, there are other ways. For example, sometimes you put the code inside brackets to show that this part of code depends on the other part of code. But in Python, everything is just based on indentation. Indentation is very handy. It makes your programming go faster and it makes it be more readable, but it's also easy to miss. So always check twice your indentations. And indentation simply means white space at the beginning of the line. The amount of the white space defines the scope of the code, meaning that to which part of the program this code belongs. Now, in case of if condition, the body needs to be indented on one level. And one level of indentation is equal to pressing tab key once or to putting 4 spaces. This is the standard. Actually, 4 spaces is the standard. So here you see we have if statement, which starts by if keyword. Then comes our condition, which is expression using OR operator. This is not a bitwise OR operator. This is for Boolean values. And then it is followed by column. And then the code inside this if statement is indented. If we miss this indentation, we will receive either an error and the code doesn't execute, or the result will be wrong because this cannot. So the indentation matters. Let's try this. So name is it is 23, for example. If name is, and you remember for saying equals, we put 2 such characters, but for assignment, we just put once. If name is equal to John or age is 43, then my condition ends here, so I put colons. Now, when I press the enter key, you see that my cursor is already moved forward to have one level of indentation. So this is because I am using a text editor, which knows how Python works and adds the indentations automatically. Otherwise, I have to put it myself. So here I do this printing. Now let's run it. So I have a syntax error. Let's see what it is. I missed to put equals twice. Now I run it again. So you see that the if body meaning the code inside the if statement was executed, and this was because the condition holds here. We have discussed it with the OR operator. The condition holds as soon as just one of the parts is true, and here name is equal to John, so this will be true and this part will be executed. Let's see what happens if I forget the indentation. I remove it and run it again. So it says expected an indented block, meaning that this block of code inside if needs to be indented. So I come to the beginning and press space key 4 times and run it again. And now the problem is solved. So remember, always you have like if statement, while statement, for statement, the code inside it must be indented. And if you have nested blocks, then you need to do more indentation. So for example, I have a condition here, then I press enter, you see that my cursor is moved already inside again, and one level of indentation is added. So now if I execute it, you see that both strings are printed out because both conditions hold. With if statements, we always need to have else statements as well. In Python, we have 2 versions of an else statement. One is called else and the other one is called elif. We see how they differ. So elif keyword in Python is a way of saying if the previous condition was not true, then try this condition. So it comes again with another if inside it. It is called elif. So we need to pass to it another new condition to be tested. But else is different. Else doesn't get any other condition. The else keyword catches anything which isn't caught by the preceding condition. So everything that was before, if it doesn't hold and it is not true, then we will come lastly to else and execute that. So it will catch everything. It doesn't have any condition. Let's see some examples. So here we have 2 integer numbers and we want to check whether or not B is greater than A. Obviously, this is not the case. So this will not be executed. We will move on to here. We have elif here. So it has like an if inside it. So again, it needs another condition. It checks this time if A is equal to B. We know this is not the case, so this one will not be executed as well. And then at the end, we have else statement, which will catch everything which was not caught before. So this statement will be always executed if none of the conditions before it holds. If one of them is executed, then we will not continue to the next ones. Recording in progress. So I just define 2 variables. And then I define my if condition. First, I want to check if A is greater than B, which I know is not the case. Then when I press enter, I will automatically get an indentation because the IDE is assuming that I am continuing in this block. But this is not the case really. I want to have elif, so I need to go 1 level back. So I remove the indentation and continue here. I need to pass a condition to elif. Recording in progress. A is equal to B. Again, I need to remove the indentation. Finally, let's print B is greater. Now let's run it. So you see, this first condition didn't hold. So the first print was not executed. So was the second condition. But lastly, the else didn't have any condition and it catches everything that arrives here. So the last print is executed. But if one of the conditions before holds, for example, let's have A and B be equal, then we will see that this second condition is executed and the else will not be executed anymore. Now let's see how for loops are defined in Python. The for loops in Python iterate over a given sequence. For example, we have already seen that we can iterate over the elements in the list using for. It is very simple. We just add the for keyword first. Then we give any arbitrary name we choose for the elements in the list. Then we use the keyword in, and then we need to pass the name of the list, followed by column. Let's try this. I have a list of numbers and I want to print them. So for number in my list, don't forget the columns. Then we can, for example, print the number itself, or I here choose to print the number multiplied by 2. You see here again, we need the indentation because the indentation shows which parts are inside the for loop and which part of the code is not. For example, when I want to come outside of the for loop, I just remove the indentation and I can print something here outside of the loop. And here let's add a check. Let's print inside of the loop. So you see, inside of the loop is printed each time a loop is executed. And then after that, we have the expression that we specified being printed out. But this statement that was outside of the loop is just printed when the loop has finished and it has just been printed once. So the indentation is very important to tell Python which part is inside your for statement, if statement, etc., and which part of the code is outside it. Especially if you have nested operation, it is very important. It is very tricky to check all the indentations. For example, I can have an if statement inside my for statement. If number is 2, print I reached 2. You see here, I have 2 levels of indentation because we are both inside for and inside if. Whenever I want to come outside of if, but still be inside of for, I need to remove one level of indentation. Let's print something here. Inside the loop and outside the if. And here I want to now change it to inside of the loop. I remove this printout. This one, or simply, no, let's keep it. So now let's try it. So you see, when this condition holds that the number is 2, this second print is printed out. And this other print is printed in every iteration of the loop. And the last print is only printed out when we go outside of the loop, when the loop finishes. So the indentation is very important. Now the IDEs are very smart and keep track of it when you go inside the block. But when you want to come outside of the block, you have to take care of indentation yourself, because then the IDE doesn't know. So here, for example, I wanted to come outside of the if, so I removed one level of indentation. With for loops, we can use two functions that are called range and xrange that iterate as well. They iterate over a sequence of numbers. Xrange is more efficient than range, so you can use them in this case. For example, in the first for loop here, we say for x, which is a number in range of 5. Range of any number which is specified here means starting from 0 up to that number, but without considering that number itself. So it will be, in case of 5, it will be 0, 1, 2, 3, 4. And for these numbers, we can do something in our loop. It's a very convenient way to have loop counters. In other programming languages, usually you need to define your counters yourself. You need to, in this case, say, my first value for the counter is 0, and it will be incremented by 1 each time, and the last value is 4. But here it's very easy. You just say, you just use the range or xrange function. And you can also give two numbers to xrange function so that you change the starting value. So in this case, the starting value is 3 instead of 0. If you don't have a starting value, it will be by default set to 0. But when you have two numbers here, the first one will be the start. And there is another case that you can use xrange, and which is to give it 3 values. The first one will be the start of the range, and the last one will be the incrementation step. Here it says each time add by 2. It can be by default, I think it is adding by 1, like we have in these two cases. Always we have an increment by 1. But if we don't like it and we want to special increment, we use this option. And the second value is, like the other cases, the upper bound on this range. So let's try this. For counter in range of 5. Here you see my cursor is not indented because this is because my syntax is not correct. I have forgotten a column. So once I put it and I press enter, the indentation is automatically set. So you see in this case 0 to 4 is printed out as expected. If I put 10 here, it will start from 5 and continue just below 10, which is 9. So you see the start is not anymore 0, it is rather 5. And if I specify the steps for it, it will not increment by 1, which is the default. It will rather increment by the specified value. So you see that the step is 2 each time. And I can have like negative values as well. So let's put the range minus 10. So each time I will be decrementing by 2. So you see here, the start is 5. Each time it is decremented by 2 until before minus 10. What if I forget to put minus here? So I am saying start from 5 and increment it by minus 2, or basically decrement it by 2 and stop just before 10. But these values will go negative. 10 will never be reached. Let's see what happens. This condition doesn't hold, so the loop will not be executed. You see, we have empty prints here because we cannot simply decrement from a positive value and reach a bigger value. So the condition sort of doesn't hold at all, and the loop is not executed at all. Now let's see the while loops. While loops, as we have seen in the previous lecture, repeat a piece of code as long as a certain Boolean condition is true. So, for example, here you see we have a variable which is set to 0. Then in the while loop, we check whether or not this value is 0 and we print that out and we increment it. So this loop will, and this special operator, which is plus equals, is equivalent to just doing like count equals count plus 1. Just this is used for kind of have a shorter code. So instead of writing count equals count plus 1, we write count plus equals 1. They are the same. So the count will be incremented each time, and each time this condition is checked, and if it holds, the code inside the while loop is executed. Otherwise, this block is exited, and the rest of the code is executed. So let's try that. Counter is 0, for example, while counter is smaller than 5. I missed the column. I need to put it. Then let's print the counter and increment the counter by 1. I can also increment it by 2 or any other value. Let's try it. So you see, we started from 0. The first time the condition holds because 0 is smaller than 5. Then this print is executed, so 0 will be printed out. Then it is incremented by 2, and it continues once again in the while loop. The condition still holds, and 2 will be printed out. Then it increments it by 2, goes back again to the while loop. The condition still holds, but the last time when it increments it to 2, it will be 6, and then it will see that the condition doesn't hold, so it will not execute here. Let's check this. So let's print the counter just after the while loop. So I will write counter is equal to, this is my string, and then I want to print here the value of the counter. So you see just after the loop, counter is equal to 6. When we have loops, there are 2 statements or 2 keywords which are very useful. The first one I want to introduce here is called break, which is used to exit a loop. Whether it is a for loop or a while loop, it doesn't matter. It just exits the loop immediately. It doesn't execute the rest iterations of the loop. The other one is called continue, which just skips the current iteration and continues to the next iteration. You can see an example here. So here we are using continue. So it is saying for all the numbers from 0 to 9, do this. So first check if the number divided by 2 gives remainder 0. Or we can say if the number modulo 2 is 0, which means that the number x is even. So in these cases, it tells it to continue, meaning that skip the rest of this for loop, which is this print operation, and continue to the next operation. And when the numbers are odd, this condition doesn't hold, so this continue operation will not be executed. So we then proceed to here this print statement, and the number will be printed out. So this essentially means that all odd numbers in the range will be printed out. Let's try it. So for x in range of 10, when we just pass one number to function range, it means that it specifies the upper bound and the starting value is 0. So we will go from 0 to 9. If x modulo 2 is 0, continue. Otherwise, print x. So you see only the odd numbers are being printed out, because for even numbers, we have continue statement, which means skip the rest of this iteration. And the rest of this iteration is the print statement. So it will be skipped. So the next iteration will be executed. And now let's see what does break operation do. So here we have an example. We have a while with condition true. Condition true is something that always holds. So it means that this while loop will continue forever. This is something dangerous to have in your program. So if you have a loop condition which is always true, then your program will never terminate. It will just execute forever and ever and ever. But here we just want to have it for the sake of example. So here we say forever print the value count and then increment it by 1. And then check something. If count is greater than or equal to 5, break. So here we have simply moved the while condition that we had before, like here, to this if condition, and we have kind of translated the previous while loop as a new while loop with which uses break. This is just to give you the idea how break works. So when the counter becomes equal to or greater than 5, then we will break, which means that we will not anymore execute this while loop. We will simply jump out of it. Let's try it. So we have a counter which is initially 0, while true. Note that when you want to use true and false in Python, the first letter should be capital. Print counter, increment the counter by 1. If counter is greater than or equal to 6, for example, break. Let's just print something out of this loop to make sure what it is doing. Counter reached. I need a space here. So you see here, all counter values were printed out until 5, and then just after, then the while loop is exceeded because we had a break statement, and then we see that just after the while loop, the counter is 6. Let's see what happens if we have a dangerous while loop whose condition is always true. You see this loop is continuing forever and ever, and it's just printing bigger and bigger values. This is dangerous. You should, if you see that you have something that doesn't terminate in your program, first check your loops to see what is happening there. Maybe you have a condition which is always true. For example, you can have some condition like this, which is always true, and this doesn't make your program terminate. This is the same, this is the equal to true. 2 is equal to 2 is always true. So this condition will always hold, and you will have an infinite loop. Let's try this. So you see we have the same situation. Let's kill this process. So we have seen some of the most popular statements in Python, which are always also very useful in other programming languages. Now let's see how a program is constructed in Python. A program can have different parts. For example, main program, the functions, modules, and some built-in Python functions. And you can also have importing other packages. Let's see what they are. The main program. The Python file that you execute directly, for example, the test file that I was working with is my main file. The Python interpreter goes inside this file and starts from the first place and executes it line by line until it reaches the end. And the interpreter will not be executing the functions that I have written. We will see how functions are defined in Python in the coming slides. But it will only execute the functions when they are called. So let's see how functions are defined in Python and why we need them. Functions divide the code into blocks and allow us to give a good order to our code. If we don't have functions, then we would just simply sequentially write all lines of code one after another. So the code is not structured, is not ordered, which is not good, especially when your programs become a little bit bigger. It is not good at all. When you have functions, your code is more readable, and it becomes also reusable because, for example, if you implement a function whose the work that it is doing is repeated so many times in your program, then the same code will be reused over and over again in your program without needing you to copy paste the code all the time. You just have to call the function. And the good functions which are written can be also shared. We can see that we have already also seen that there are some built-in functions. They are simply functions that some programmers have written, and they are so good that they are shared, and we also can use them. So a function is defined like this. First, we need to write the def keyword, means that this is a definition of a function. Then we need to give our function a name. The name should be meaningful. It should reflect what the function is doing. It should be followed by an open and close parenthesis, and it should be followed by colons. Then inside the function, the code needs to be indented. So the function I just showed you didn't have any input arguments. It had just empty parentheses here, but basically inside this parentheses, we can have our input arguments. For example, here we have another function that takes two input arguments and has a print that uses those input arguments. And we have a special print operation that I will explain to you as well. So let's use this function. So I want to define a function here. So the names of the functions are like the names of the variable. They should be unique. And the variable and a function cannot have the same name. So print hello. This is saying that a string which will be given as an argument will be placed here. And then after that, I want another string that I will pass as an argument. So we can pass arguments to the print as you see. So for passing arguments, we need to put the percentage character. Then we write the arguments. So what I aim to do is to write hello followed by the name of the person, followed by exclamation mark, followed by a greeting message or a welcome message. So far we have not yet seen how we can use this function. We will see it later on. So you see here our function doesn't have any return statement yet. So because of that, it will be also called a procedure. Procedures are functions without any return value. We can have other functions that you see an example here. So in this function, we have a return value. Sometimes the names functions and procedures are used interchangeably, but if you want to be very exact, functions are those that have a return value, but procedures do not. So let's implement this function as well. I need to remove the indentation and write the function name. Then I have forgotten the column, both here and here. And then I want to return it. Returning is done by using the keyword return. And I want to return the sum of these values. Let's see what happens if I execute this file. This is my main file, but since there is no code in it except for functions, nothing will be executed because the Python interpreter does not execute functions. It just executes functions when they are called. And procedures, as we said, is simply a function without a return value. Now let's see how we can call functions. We use functions when we call them, otherwise they are just useless. So we call our functions inside our code by just giving the name of the function and passing the desired arguments to the function. So for example, here in my code, I can write my code like this. So print func with the name and I will also print my other function with two numbers. Sum is, so you see the sum keyword is used, so I add underscore to it so that I can define my own variable. So I want to store the result of this function inside this variable. So I pass two numbers to it, and then I print this value. So let's see. Execute it. So you see the first part here at line 8 calls this function and substitutes in the print string these two input arguments. It has substituted the name and the welcome message. And then the second function is called, which will calculate the sum of these two values and store it in this variable. And then I have printed out that variable. So the functions are simply called by their names and passing their input arguments to them. Here, for example, I am not writing A and B. A and B are just some names that the function is using to know how to treat the input arguments. I will not use them. I will instead just pass or give the parameters I want to the function. For example, here I can give it two variables that I have already defined. I need to define them. X is 10, Y is 20. So you see here, those two variables are passed to the function and their result is calculated and returned and printed out. So when you write functions, you can share them. And in Python, there is a long list of built-in functions that are shared and we can use them. We have already seen some of them. For example, the bin function, which returns a string that contains the binary representation of an integer number, or we have used many frequently the print function, we have seen the range function, and so on and so forth. I have highlighted those that we have used in this lecture.
Now let's talk about the concept of modules in Python. When you write a program that gets a little big, it's not good to write all the program in a single .py file, because then it is not very easy to test it, debug it, or continue working with it. What is used is instead modules. So module is simply a piece of software that has a specific functionality. And in Python, modules are Python files with a .py or .py extension. And each module has a name, which in this case simply be the name of the file without considering the .py extension. A Python module comes with a set of functions, classes, variables, constant, which is defined inside it. And if you want to use the content of a module, you need to import it. Importing means that you allow your program to use that module. You tell it to use that module, and it is done simply by using the import keyword followed by the name of the module. For example, in this case, we are importing the math module in Python. Math module provides mathematical constants and functions, and it is when you install Python on your machine, you have also access to math module. And what you need to do is just to import it, and then you can use the constants and functions in it. For example, the constant pi or the functions cosinus, sinus, etc., and many other functions. You can Google what functions are defined in math. Let's now see with an example. So imagine I want to use constant pi, but first I forget to import math and I simply just do print pi. And I run it. I get an error which says name error. Name pi is not defined because pi is not yet any variable defined in my computer, in my program, and it's not imported either. So I get this error. So now let's import math. and run again. This is not going to work now either because it is not clear whether or not pi should be defined in my program. I have not defined any variable pi in my program, and my program doesn't know that it is inside the mass module. I have to tell it explicitly. So what I have to do is to write mass.pi. Then it is going to work fine. Then you see that the value of pi is printed out. And I can use the functions inside mass in the same way. So let's print cosinus of mass dot pi, for example, divided by 2. Here I am getting an error again because this name is not identified. So it seems that I have forgotten to put mass here in the beginning. This mass dot tells that this function, or for example, this constant, belongs to the mass module. Now I run it. I see I have a syntax error. Let's see what's the problem. I needed to divide it by 2. Okay, now it should work fine. So now here we have the cosinus printed out. You can define your own modules. What is special about a module is that it needs to be a .py file or .py file, and in there you need to put all the functions or the variables, constants that do a specific task or have a specific functionality, and then you use it later on in your code by importing it. So thank you for your attention. If you have any questions, please reach us either through the forum or by emailing us or joining the drop-in Zoom sessions. I have left the doodle poll for knowing your time preferences for the drop-in Zoom sessions. Please go to the link. I have already emailed it to you. Even if you are not interested, please go to the link and check the not interested option so that we know whether or not you are interested. And if you have a special time constraints that are not specified in the poll, please tell us either by emailing or writing to us in the forum. Thank you for your attention. You will have Python assignments to do based on the lecture we had today.